Hi, and welcome back to the Decarb Connect podcast. This episode with Jan Skjoldhammer of NoviOcean is actually the first in a short little series we're doing for December, really focused on innovative technologies. And this week, Jan and I are going to be talking about the role that ocean energy, wave energy, can play in our overall energy mix, and also talking about some of the questions around current energy instability, particularly as seen in the European market. So we'll be covering a bit of ground. Jan, welcome to the podcast. Maybe you could kick us off just by giving us a sense of how have you arrived at this point in time? So how have you found yourself at the helm of this kind of innovative technology business?
Well, thank you, first of all, for having me. Pleasure. I might have a bit different background from some of the normal engineers which are working in the industry. My education is as an officer, economist. Later on, I've been an airline captain for the last 25 years. And then also did some property business while flying. But the whole time I had in my drawer laying different patent ideas, many other ones on the market by other people so far. But I had this solution for wave energy laying there since I was 25 years old. And then when I knew about the emerging climate crisis coming up, and I had some liberty after the property deal, I asked myself what to do now the rest of my life. Shall I just keep on flying for the next 15 years or do something more sensible? So I weighed that for like 1 year, because it's a big step to quit a very nice job, good salary, status, nice colleagues. But I decided, so I quit my job as an airline captain there and started this thing. And since then, I've been working double the number of hours, I think, per year as I had as an airline captain with no payment, but it's meaningful. And I think we're going to make big impact for the environment over time. So it's worth it.
Yeah, I think for all the disruptors and innovators we talk to, if you don't feel that purpose is there, you probably wouldn't get through the first few years of kicking off with new technology, would you? But just before we move on, so you mentioned you'd had this in the drawer since you were 25. So what were you doing at that stage? What had you studied that kind of led you to this kind of idea?
Well, I have this innovative mind. So I've been drawing up things since I was a teenager, and seeing them going with other people to the market, like carbon skis and different sort of sports equipment and some racing boat system, the endocrine aircraft going low over the Caspian Sea, for instance, and also some solution for aircraft safety. And that kind of made me a bit pissed off seeing everything other people have taken it to the market. But this one was laying all the time, and I was always curious about it. And when I had the chance, I said, why not go for it and make the best out of it? And if it will be successful, which I think it will be a game changer in renewable, stable energy.
Okay, well, that's a good intro then to our kind of first point of discussion, which is that we're recording this podcast in actually the first day of December 2021, and it's been quite a strange few months for those looking at the power and energy markets in Europe in particular. Maybe, why don't you give us the scene as you see it? We're going to be talking more about your technology, but right now, give us your view of what's going on in the energy market in terms of renewables and traditional power, and then where does wave energy potentially fit into this?
Yeah, very good question. Well, as far as I see it, there are two main reasons for the high prices nowadays and volatility. One is of course, the high prices from Russia coming on coal and gas power from that side, which might be due to profit, let's say, increases or wishes. But the other one is the increase in the amount of unstable or intermittent power in our grids from solar power and from wind power, not the least. And when this varying power is there, then of course, when there's wind for 15 days, then the coal powers and gas power plants shut down. But when they have to open up, just perhaps 1 or 2 weeks per month, they would charge much more for those few days because they also have the operating costs to be covered. So they are more expensive when they have to kick in, combined with the high prices for the fossil fuels they're burning. That's why we have this problem. Had the grids been much more stable from wind power and sun power, this wouldn't happen. But by nature, they are unstable. So that's why we see the good combination coming in for wave power, because it is off-phased with wind power in particular. To say that the way it works basically very simple is that, of course, first you have the sun coming on. The sun warms the air, which creates wind. The wind blows for a few days. The wind creates the waves. And then when the wind dissipates or calms down, the waves remains for days. And that's where we have the natural stability of these three green energies, wind power, sun power, and wave power. Because then the wave power can supply the grids with directly green energy for days when the wind is gone, and also, of course, cloudy days and at nighttime. So the combination is what we're looking for. Otherwise, you have to have storage like battery storage, which also is expensive. It doesn't create any energy. There's a storage or hydrogen, also good. All can be combined, but the directly produced energy from the waves will be the best option to keep stable and green energy coming to the grids.
So the way that we should be thinking about this is not as necessarily totally separate sources of energy, but more like a kind of nice virtuous circle of sun to wind to wave, and looking at it as a whole. Is that
correctly?
Yeah.
It's called the energy mix, and right now, of course, wave power is a very small portion of energy mix. But believe me, it will become larger by time because of the need we see right now. The last 3 months is a proof of that. People have been hoping it wouldn't be like that, but I think actually the more we now get in the grid system from unstable producers, the worse the problem will be. So if you think you are suffering nowadays, it could actually be much worse in 3 to 5 years if we do not get more of these green energies, which are more stable.
Okay. All right. Well, then we've sort of set the scene of where we are this year and the kind of challenges for stable electricity, particularly in Europe, but not only in Europe. Let's look now very specifically at the wave energy business model, and we will come on to your specific technology, of course, but tell us a bit about like what's needed if you're someone who's looking either at investing in or using the power from wave technology. What is actually needed in infrastructure and business model terms to make that real?
Yeah. It's actually quite the same story as wind power had and also sun power had when we were developing. They can both create electricity, and we can as well. And it has to be tested first at smaller scale, then at pre-commercial areas, and then larger areas. And they all have a learning curve, most costly in the beginning, and then as you have more and more production going on, the learning curve is falling down, or curving down, so you have lower cost per produced unit. I might mention that in the beginning, wind power had a cost of 50 to 60 cents per kilowatt hour, but then the governments came in with subsidies, and slowly but surely over the last 30 years, the costs have been falling down. And the same will happen also with wave power. But there's one difference. Many wave power concepts are expensive, but for instance, ours, it looks like we should be starting out at a cost of less than 16 cents per kilowatt hour for the first 3 megawatt array, which is very low. On top of that, you add the same learning curve, which is steeper in the beginning and flatter after a while. So if you're starting out at perhaps 30% of what wind power had, add the same learning curve, then you might see that it will become below offshore wind in cost in some years. And the market is enormous around the globe, both for the climate cost by using green energy instead of fossil energy, but also, of course, the economical side.
Okay, and so, sorry, I was about to ask a very bad question, so I'm going to edit myself out, don't worry. So right now, tell us kind of a bit about, sorry, let me start that again. So as you and I are talking, Jan, obviously I can see, because we're on Zoom together, kind of an image of the technology that you're developing behind you. Sadly, podcasts are not known for their visual communication of ideas. So can you talk us through, what does your technology look like? What does it do? How does, in layman's terms, what is it that your technology is able to bring to market?
Just a good question. First of all, the listeners, most of you have a phone nearby or a computer. Google up NoviOcean, NoviOcean. There you will see the homepage, and you can see some videos in that page showing how it works, and also some numbers, etc. Basically, it's a rectangular large float. The full size will be 38 meters long, 8 meters wide, and 4 meters high. And it lays in the ocean naturally with the long side towards the wavefront. So when we are in the deepest of the wave, we lock one valve. It is connected to the seafloor by a hydraulic cylinder, and on top there's a Pelton turbine, water turbine. So it is locked hydraulically in the same position vertically. Then the wave is rising up alongside the float and locking up to 600 cubic meters of air below water. That's 600 tons of lifting force, 400 cars. And when we have the pressure we want, we open one valve, and high pressure water streaming upwards towards the Pelton turbine, hits the turbine on the side, bang, up to 1,000 liters per second, 20 kilometers per hour, turning a water turbine around, spinning a generator. It's actually the same as you have up in the mountains, a hydropower plant. There up you have a dam, large dam, and down comes a tube, sometimes several hundred meters long. In the end of the tube, you have a water turbine and generator. We just took that concept, well proven over 200 years, put it out on the float, coupled to a hydraulic cylinder, and there it goes. So it's well proven, light, few simple parts. That's also why we have gotten some awards, for instance, for what we're doing, because professors, doctors into renewable energy do believe that we might be one of the few ones that can make this transition happen very soon, actually, as well.
And in terms of what happens to the power generated, I know there's kind of two versions, right? There's the stored version, and then there's the, I guess, cable to shore, but perhaps you could just talk us through that as well.
Yes, the wave energy does the same as wind power. You have producing energy by electric generator, and in our case, it goes into land via subsea cable, just like wind power. Difference is wind power have to be out to coast, perhaps 50 kilometers, because they're so huge and no one wants to see them or hear them. But wave power is much less visible, and it doesn't make any noise or any significance, and it doesn't harm any animal life. So it can be very short, close to shore, and it doesn't disturb anyone. But that's how it is out in the sea. But the cable gives them power into the grids, just like wind power. But on board, we will also have supercapacitors, which is sort of a fast battery that will be charged in every cycle, you must say. And we can have an extra capacity, so we can, let's say, store, for instance, 2 to 3 hours of energy on board. So in the morning hours, when there's a high demand for energy, and also in the afternoon, we can supply more energy in those hours and store it during the, for instance, nighttime. So we can help to even out even more of the grids. This is important, for all, areas, but especially for small islands, for instance, which for us might have just 1 or 2 units supplying power, then we can, help them with the supply 24/7. And then lastly, we can also, in a second iteration, produce hydrogen on board with electrolyzers, store it, can be offloaded to the consumption in, for instance, the UK or Japan, where it's needed. Or we can also use that, if wanted, to be supplied back to the grid in those hours when more energy is needed by using fuel cells. So we can have this sort of 2 sorts of storage depending what the user actually wants to have. We have it all.
And then in terms of like, what would it look and feel like? If you imagine your wave energy farm or cluster or whatever the right terminology is, what's your sense of the kind of the seascape of it? How much space would that take up? And you mentioned it's closer to shore, but how much closer to shore could it be?
It depends on actually the depth of the ocean floor. We can be from 30 to 80 meters depth, depending on the wave heights in that area. That would normally be closer than wind power. Can also be in the same location where the depth is the same. But we might go deeper, but that's the second stage then, the third stage. It can be combined with the same cable as wind power has, for instance, or it can be co-located in the same area. But since water is so much more dense than air, you can extract, according to calculations, about 3 times more energy per sea area, by using wave power than wind power. So we get more bang for the buck, so to say. And also, a little additional thing, important perhaps for California, they see now the large nice villas falling into the water because of the shoreline erosion. If you have an area of wave power along the coastline, you'll also be able to mitigate or reduce the waves hitting the shorelines. So for California, for instance, we can produce both electricity, hydrogen, and protect the shoreline. Not visually obstructing, non-noising, not harming the animal life. Is the dream scenario, in my opinion. Welcome to Connie.
And what stage is NoviOcean at the moment? So where are you at in terms of being, demonstration, pilot, and so forth? What phase are you in?
We are so-called in phase number 3, according to Ocean Energy Systems scale, which means again TRL level 6. That means technical readiness level number 6. And then of a 9 level scale. That means we have tested it both in wave tanks, in Plymouth and in Nantes in France, and also offshore outside Stockholm. And now it goes out again this winter, by the way. Freezing cold it will be. It goes out again for 7 months of testing, just to have more hours under the belt. This is to the 1 to 5 scale. At the same time, we've now gotten funding from the European Commission or European Union by the LIFE project, about 2.2 million, plus about 400K from Sweden, which covers about 50% of the cost for the design, construction of the full-scale unit, the 500 kilowatt unit I just mentioned. And so we'll be at the same time now working on that design, and then using suppliers out in Europe to put this together. And actually, we'll then also need to cover the half of this budget of 5 million by private capital in some way. And so hereby I invite the large industrials, large utilities like Enel, EDP, Engie, and so forth, and other companies like Shell, BP, Equinor, come on board, put in some pocket money from your side, 3 million, and come along, develop this thing together with us. Later on, you'll be on board on top of this one, taking along your VIP friends, politicians, media, having your name displayed in a 35-meter long placard on the side there. It's the best investment you will do, and you will have fun at the same time. So don't be shy, and don't wait on the sidelines until someone else comes on board. First one will be the winner, in my opinion. That was today's commercial.
Well done, well done. So investment ready, and already had demonstrations in open water and deep ocean water. So that's kind of an exciting stage to be at. Well, let's kind of switch focus then for a minute. So you mentioned there that you have some funding from the EU. I know when we were doing the prep call for this, that you would also mention that the EU has actually made a stated goal around wave energy, ocean energy, as part of their net zero 2050 plan. So what is that set goal? And yeah, tell us a bit about that.
Yes, very a good question. Well, the logic is the same as also with wind power. They've been subsidized now by all taxpayers for 30 years. And the cost was in the beginning 3 times higher than what we will have. So, but now the European Commission has decided that they will commit themselves to see 40 gigawatts of unit out in the water by 2050, both tidal power and wave energy. And they will use subsidies as needed to see that happen, together with the other countries with the shoreline in Europe. And 40 gigawatt is just a number. It doesn't mean so much for most people. But in our case, it means if we just take 10% of that market, it means 8,000 units, the one behind me. And that means, again, a turnover of 16 billion euros approximately over those coming years. It's a huge turnover. And of course, the global market is much, much, much larger than that again. I'm personally in this for the climate thing. 60% I do this for the climate, 20% for the money, 20% for the project. So, but for the guys thinking mostly about the business side, there's a huge profit waiting there for anyone coming on board, investors and industrials. Of course, also the latter one will have easier to employ young people to attract them because they're working with green energy. They're showing some guts, perhaps coming on board early, not waiting on the sidelines, waiting for us to be larger. The first one will be the winners, I think, in attracting, new skilled employees and having the green image for real, not greenwashing, but so be brave, guys, and think about this and talk to your parents, perhaps, if you're a young listener, and tell them to check out our site and look more about this because it's going to happen, and it's important to be early on, not later on.
Now, with our investors and industrials in mind, obviously the 2 questions that everybody wants to know about a new technology is what are what's the reality of the economics around this? Like, what's the cost now versus what the path to price parity with other forms of energy generation might be? So that's question 1. Question 2 is, what needs to happen between where you and companies like you are now and 40 gigawatts having been deployed? Because obviously there are other things that need to fall into place that are not all in your hands. So maybe you can talk us through that. Let's start with that second question. So what is it that needs to fall into place to really realize that vision of 40 gigawatts of tidal and wave energy by 2050?
Yeah, for our specific case, then we're now at stage number 3. That means we are now in 3 years, we will be deploying the first unit out in the water and for 1 year of testing. And that's called the pilot. And then after that, you will have a pre-commercial area for another 2 to 3 years with perhaps 3 to 6 units out, doing work, producing some work. And all this, proves the system. You take away some initial problems and, lowers the insurance cost, for instance. After that, you're fully commercial, just like wind power, went through the stages. And also like, for instance, floating offshore wind does the same thing. So it's the same procedure. And what is needed is just then the required feed-in tariffs. That means the price per kilowatt hour must be raised by the governments to a level that makes it possible to be profitable, or it can be capex or OPEX subsidies, maybe a combination of all these. Could be different from country to country as well. This will happen then and pull us and others through this let's say conversion process. And of course, now there are many companies out there producing or trying to develop wave power and tidal power. So the challenge is for the companies out there to try to find out who is the best one, or who are the best ones, because there will be perhaps 5 systems out there in 15 years that will be the dominant one. So your challenge, guys, is then to look to us, contact us, talk to us, try to evaluate. Is it us? Is it Core Power? Is it Minesto? Is it Motion? Is it someone else? But talk to us, check our systems, and evaluate the best you can. I can mention, for instance, Ecopetrol now in Colombia. They are on the front there. They've been contacting now, like I think 20 developers all around the world, because they've set forth, because they want to see this in the water. So now we had like 4 or 5 interviews with Ecopetrol about this. Also PTT in Thailand. They're starting this process because they know it's going to happen. So it's just up to Equinor, Shell, BP, Engie, EDP, all those companies, do the same thing and try to be early on, not be on the fence.
And then on the economics question, so there's always a lot of interest, isn't there, with a relatively new technology about how long does it take to get to where there's a real kind of comparable price with traditional established technologies. So what's your view on that?
Yeah, well, the official cost number for the initial stages from wave power is from about 300 to 600 euros per megawatt hour, from 30 to 60 cents, which is kind of high. Some of us claim lower, some higher. Most companies do not even show a number on the web page. They talk about the rate of power. They don't show what the output will be, because rate of power doesn't mean a thing, in my opinion. It's the annual delivery which is important for to pay the bills. I guess we're the only company showing all the numbers on their web page and in documentation because we can. So our numbers are quite low. Our first 3 megawatt array will have a cost in medium sites at about 140 euros per megawatt hour, which is very low. Most likely the subsidies will be above that because of the commitment of the European Commission, starting most likely at something like 150 to 200. So even the first 6 units should be profitable. And then that subsidy will be coming in at a fixed rate, most likely for many years. And while our learning curve is going down rapidly. So we're saying when we have 50 megawatt deployed in the sea, the cost should be well below 100 at the medium site. And then by learning curve, when we come to some gigawatt, will be down to 25 or 2.5 cents per kilowatt hour, or 25 euros per megawatt hour. Then if that happens, we are below any other energy source in cost. It might sound like a fairy tale right now, but we think it will be happen, and we are quite certain about what we're doing. So welcome for a discussion if you are among the early adopters.
Well, we'll make sure that in the podcast show notes, we provide links, not just, we'll put a link obviously to the video, but perhaps we can direct people towards that part of your site as well, because I think, understanding that and being upfront about that is quite refreshing, isn't it? So getting people face to face with those numbers early on so they can make well-informed decisions, I think, yeah, a great way to approach it. So I've sort of talked about those 2 areas of questioning that all technologies get, which is cost and the timeline to deployment. With wave energy, and there are other technologies in the climate space that have this similar kind of challenge, which is, this isn't the first cycle. This isn't the first time that we've seen technologies talk about the promise of wave tech. So I'm sure that part of your job is kind of overcoming skepticism from those that saw it the first time around. So what sorts of pushback do you get, and how do you overcome that when you're in the kind of the second iteration, you're in, wave tech 2.0, how do you overcome that kind of skepticism?
Yeah, very good question. It is a challenge because there have been so many companies which have been early adopters trying to support, for instance, Pelamis and Sea-based and other ones, putting in lots of money in those things, and I think all the glory to those companies, and governments haven't done that. It has so far not been very successful. Many have failed. It is mainly due to the technique has not been the proper ones. Very often, up to 1,000 ton per rated megawatt hour, which is too much high tech out in the sea, perhaps enough just to run a car at the best. It's just too costly. So now the challenge for us is to convey to the investors and the industry that we have a system which is very light, based on few and well-proven parts, like the hydropower plant. You've seen it for 200 years out there, and hydraulic cylinder, it's been used for any car, any tractor for the last 150 years. So it is the same system, and we just have to show that it's simple, light, and durable, and then have them have a look at it and check our numbers. We can scrutinize how much you like, and we can stand for that, and then we'll hope that these companies that have been scared before say, well, let's give it another try, because the ones that are in early will be the winners on this, both the investors and the companies taking the chance.
Mm. And as you said at the beginning, I guess the kind of a really great lens to look at this through is for people who are investing or looking to invest in other forms of renewables. This kind of completes that mix. It's not just a kind of a standalone technology. It's a way of managing and balancing out your renewable portfolio of investments. But yeah, great. Well, look, we're going to wrap up then. And as always, I'm going to ask you, like, what's your call to action, not just for investors, but for people in general listening to this? We know that obviously you're keen to talk to potential investors, but what's the call to action that would help wave energy, ocean energy kind of take off? And how can others help with that?
I think media, just like you're doing right now, is important to be out there and to people understand this anti-phasing with wind power and sun power. If you combine wind power and wave power, the base load, that means the lowest delivery to the grid, can be 4 times higher. It's like nuclear power, this combination. And since we have all this wind power out there now, if we just keep on adding, sensible wave power, we will solve this. And it's also much better for the climate, because if you produce tons of batteries storage to support the air times when there's no wind, it's also an expense for the climate. Taking minerals from Congo and transporting it, building batteries, transporting them, burning them, recycling them, is difficult. So can we have a larger amount of green energy coming out there? It's in total much better for the climate. Our LCA shows we have 1 year carbon payback time. It's nothing. Then you go with profit. If you have some power panels made from China, with coal power, it is not so desirable from the carbon payback angle. So I think people should look about the 2 ways, both for the climate and then also for the grid stability. And thirdly, also the ones that run a business, look at the enormous profit waiting out there.
Okay, great. Well, thank you so much, Jan. And for those who are interested to learn either more about how the technology in this case works, or to find out more about some of those stats and financial models that Jan has referenced, we will in the show notes. So have a look in our show notes. You'll be able to find some links to that information. But Jan, thank you so much, and good luck with this next phase of testing this winter.
Thank you. If I might add, then you can also find me on LinkedIn. Connected, that's the easiest way to get to contact me or our staff, and then we can have a more discussion that way. Thank you for having me.
Thank you. Many thanks for listening to the Decarb Connect podcast. We work with clients across the industrial sectors, specifically those who are tasked with decarbonising the most energy-intensive products and materials that we use every day. If you have an interest in learning more about either our members network
our reports or our event series, do get in touch with us at decarbconnect.com. Or if you'd like to take part in the podcast, email me, Alex, at ac@decarbconnect.com. Thanks for listening.